at square roots with variables and so forth. We just did some real quick stuff last time with square roots of numbers, which generally is stuff that students have a background for, okay? One thing that I want to begin to look at is, starting up here, is what you do if you have a square root of x to a power, okay? Now remember, if you've got a square root, like if you have something like the square root of 9, well, what are you looking for? You're looking for something you multiply out twice that would give you 9, correct? So if you're doing the square root of 6, what would you multiply out twice that would give you x to the 6? There's only one thing. What would it be? Let's try something. What if you did x to the third times x to the third? What is that? X to the 6, because you add the exponents, right? Okay, don't forget that. Okay, so the answer to that problem would be x to the third, because you multiply that by itself, you would get x to the 6th. Okay, now let's look at the square root of x to the 50th. Okay, just think to yourself, what would you multiply out twice that would give you x to the 50th? Tell me that now. X to the 25th, good. Okay, so that would be x to the 25th. Now the answer is x to the 25th. This is the y part, okay? You write the answer, but that's y, okay? So we're going to see a pattern. I'll do one more of these real quick. What if we had x to the 100th? What would that be? What are you noticing? Half, right? Okay, we're doing half of the exponent, exactly. That's it. That's all you do. So we're going to be able to whip through these very quickly. X to the 36, what's the answer? X to the 18th, sorry. Okay, it's half of the exponent, right? Half of the exponent, okay? When you were thinking 6, you were thinking square root of 36, okay? That's normal, okay? So the reason is because x to the 18th times x to the 18th is x to the 36, or you can look at it this way, x to the 18th squared is x to the 36, okay? When you have an expression like this, if you have two exponents, like an 18th power to a second power, that's when you multiply exponents. So you can look at it that way too. Okay, but you need to understand the y part, or you'll forget this the minute you walk out the door today. What's the answer to number 15? X to the 4th. Okay, you can think of it this way. X to the 4th times itself gives you x to the 8th. Or if you square x to the 4th, 4 times 2 is 8. Does that make sense? Okay, what's the answer to the next one?
9x to the 3rd.
Good, 9x to the 3rd, because we know the square root of 81 is 9. We know half the exponent. And the reason, if you do 9x to the 3rd times 9x to the 3rd, you're going to get 81x to the 6th. Okay, like that. Or look at it this way. Take the answer and square it. So if you do 9 to the 2nd, that's 81. If you multiply 3 times 2, you get x to the 6th. Okay? How about the 17? What's the answer? 6x to the 7. I'm not even going to do that. You get the point, hopefully, right? Okay? All right, everybody got it okay? Okay, so you do half of the exponent. That's kind of the key thing. Okay, now we're going to kind of look for a pattern. We're going to begin to go on to a third root, and we're going to look at higher roots here too. So if we do a third root, let's start off by just doing some numbers. We've actually done this because we did cubes. We did the sum and difference of two cubes factoring. So if you're doing a third root of 8, all that really means is it's different now. What do you multiply out 3 times that would give 8? 2. So the answer is 2. That's the answer. The reason is because if you take that answer and multiply it out 3 times, you're going to get 8. Or if you take that answer and raise it to the third, you're going to get 8. Does that make sense? Okay. What if it was like a fourth root? What do you think that would mean? You find something you multiply out 4 times that gives you the number. That's what it is. Okay. That's the extension of the idea. Okay. If we have this one, what number would you multiply out 3 times that would give you negative 27? Negative 3. Right. So the answer to this problem is negative 3. Okay. And if you multiply 3 negatives, think about that for a minute. If you multiply 3 negatives, are you going to get a positive or a negative? Going to get a negative. Because a negative times a negative is a positive, then a positive times that leftover negative is a negative. Okay, so that's okay. You'll get a negative answer in that case. Okay, Let's look at this one now, because we're going to try. You'll find that there's a lot of real simple tricks you can do in this section. How about this one? What would you multiply out 3 times that would give x to the 12th? What do you think? X to the 4th? Let's try it. Okay, if you do x to the 4th, okay, and what you see on this is, remember, when you multiply, you're adding exponents, right? 4 plus 4 plus 4 is 12, so that's got to be the right answer. Everybody got that? Okay, so that's going to be x to the 4th. Okay, and you could check it this way also. If you did x to the 4th to the 3rd, if you do this problem, you're multiplying those exponents to get x to the 12th, like that. Okay, so here's what you're going to find. What's 12 divided by 3? That's how you get it. Okay, you just do that divided by that, and boom, you got it. That's how they're going to work out when you have powers like that. Okay, so that's what I'm kind of asking here. In general, to find a cube root of a power of x, this is supposed to say divide the power of x by 3. So on that problem we just did, you can write a note if you need to, 12 divided by 3. Okay, that's how you do that. So it ends up you're doing division. Okay, and the powers of x that have a cube root would be multiples of 3. Okay, now what do I mean by multiples of 3? Just count by 3s. 3, 6, 9, so forth like that. So I'm going to have you do some problems here in a second. Before I do that, though, let's just kind of do one more kind of quick thing here. What if you had the cube root of x to the 15th? You know what that would be? X to the 5th, right? It's real easy. What if you had the third root of x to the 30th? What's that? X to the 10th. So that's what you do. Okay, that's it. Okay. All right, go ahead and do the, go down to number 24. I'll walk around and see if you're on the right track on these. Yeah, you're going to get probably tired of filling all this in, but I do want you to fill this stuff in, okay, whether you like it or not, because that's how you understand this. You have the ability to tell you're correct on these problems, so it's important that you know how to do that, okay? Let's see. So what did we get for cube root of 64? Let's just make sure we're all on track. Back on 19, what'd you get? 4, okay, right? Okay, all that means is 4 to the 3rd is 64, okay, when you go backwards. Or you can think of it as 4 times 4 times 4 is 64, okay? I want you to fill out the y part because you have to understand that, because you can check. How about number 20? What'd you get on that? -3. Okay, it has to be a negative too. Okay, the reason is if you multiplied out, if you took -3 and raised it to the 3rd power, you would get that. Okay, you guys understand that if you multiply out 3 negatives, you're going to get a negative answer. Is that good? Okay, all right, that's important. How about the next problem? -2x to the 2nd. Good. Okay, remember, you just do 6 divided by 3. That's what you do. Okay, the reason is if you do -2x squared, now see, make sure that you understand this right here. If you do -2 to the 3rd, that's -8. But when you have a problem that looks like this, you multiply the exponents. So 2 times 3 takes you back to 6. And I don't know if all of you know that because we haven't seen this very much. If you did like x to the 2nd, 2 to the 11th, that's x to the 22nd. Okay, have you guys seen that before? I bet you have, but we hadn't done much of that this semester. So that's when you multiply exponents, okay? All right, and then this one you could look at is, yeah, if you multiplied that out 3 times, you would definitely get -8. You add the exponents when you're multiplying, so that's x to the 6th. Okay, 22. Did the fraction freak you out, or did you get the answer okay? There you go. A lot of times fractions just freak students out. What you're doing on this is you're doing cube root of 1 over cube root of 64. Cube root of 1 is 1, right? Cube root of 64 is 4, so it's 1/4, okay? So the idea would be when you multiply fractions out, you've learned you multiply straight across. So if you multiply 1 out, you get 1. You multiply 4 out, you're going to get 64, okay? That's the y part. When you see fractions, don't let that bother you, okay? All right, everybody okay? Okay? All right, next one. Now, see, this one might be one that you might have trouble doing in your head. I'm going to show you how to do this on a calculator in a minute. But what did you get?
6x squared.
6x squared, okay? You will find that if you do multiply your answer out 3 times, 6 times 6 times 6 is going to be 216. You could use your calculator to assist with that. And then the exponents 2, 2, and 2 add up to 6 like that. That's the idea. Okay? Or if you cube the 6x squared, 6 to the third is 216. 2 times 3 is 6. I want you to know how to check that either way. Okay? And the checking is really important when the problems get more complicated. Okay, what did you conclude on 24?
Negative 5x to the 10.
Okay, x to the 10th, y to the 12th. Okay, is that what we're getting? Okay, all right, I'm not going to check that one. I'm sick of checking them. Okay, all right, but I want to do that enough so that you understand you have the power to tell you right. Okay, all right, let's move on to the higher powers then. I'll talk about the calculator here in just a minute. I want to go on to, if I say an nth root, that just means any root. Okay, any root. So we could have like a 5th root, we could have a 100th root, but it all means the same thing. So if we're going to focus just for a minute on like a 4th root and a 5th root. So if you were working out the 4th root of 16, y to the 20th, well, what it means is, what would you multiply out 4 times to get 16?
2x to the 5.
It'd be 2, right. If you did 2 times 2 times 2 times 2, you would get 16. Now, I'll tell you what I see students do all the time. A lot of times students will multiply like this, 2, 4, 6, 8. Now, what do? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, correct? So you know that's 2. Now, what you do is you divide. This will always work. You just do 20 divided by 4, then that will give you y to the 5th power, okay? So I'm going to kind of show you how this checks. Okay, so the answer to this problem is going to be 2y to the 5th like that. Super easy to do, okay? Now, if you check this, notice that what happens when you add 5 plus 5 plus 5 4 times? What do you get? You get 20, okay? Or if you look at it this way, taking your answer 2y to the 5th to the 4th, 2 to the 4th is 16, then what do you do with the 5 and 4 here? You multiply. So 5 times 4 is 20. You're right. Is that clear with everybody? So see, once you kind of understand how a square root and a cube root works, they all work the same way, okay? So what you could do on a problem when the numbers get big, what you do is just kind of go backwards. Like on this number 5, since it's a 5th root, you would try to find a number you multiply out 5 times, it gives 243. And you can multiply 2 out easy in your head. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's wrong. So what would I do next? Try 3. Okay, you might get to a point where you need a calculator. This goes like this. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 is 243. With practice, you can do that, okay? So that means that's going to be a 3, and then you do this exponent 10 divided by 5, and you get the answer of 3z to the 2nd like that. Problem done. Now, what you want to start doing on your checking is start doing it this way. When you get into your 3rd exam, I again give you credit for checking, okay, extra credit. The way I would want you to do this is like this, and you do this all in your head. Take your answer, raise it to the 5th power. So 3 to the 5th is 243. Then you would do z to the 2 times 5, so that would be that. That's all you got to do to tell you right on these problems over and over again, okay? Okay, let me go through a couple of more things on this. This says, in general, if you're going to find a 4th root, you're going to divide the power by 4. That's what we did on this problem right here, is we did 20 divided by 4. If it's a 5th root, we divided that exponent 10 by 5. So if it's an nth root, we divide by n, whatever that number is. So that's how you do that. Okay, next 2 problems are real important, so I want to think about this. This question says, can you take an even root, which would mean a 2nd root, 4th root, 6th root of a negative number? Okay, let's just experiment and find out. Let's take the 4th root of negative 16, for instance, okay? 4 is an even number. We're doing an even root, right? Okay, now I want you to think about this. What a 4th root means is multiply the same number out 4 times. Can you think of any number that you would multiply out 4 times that would give you negative 16? No. No, why not? Okay? What would happen if you multiplied out 4 negatives? What would you get? You get a positive, right? What if you multiplied out 6 negatives? What would you get? Okay, see what I mean? Okay, so what's happening on this is this one's impossible. You cannot take an even root of a negative number. This one right here, we would say, is no real solution. We wouldn't have a real number solution to that problem. Okay, is that logical? Tell me. What happens every time a negative times a negative meets? It's a positive, right? So what would happen is if you have like an even number of negatives, that's positive, that's positive, that's positive, right? So it's positive. What happens if you have an odd number of negatives? You have a leftover negative. Does that make sense? Okay, so anytime you multiply out an odd number of negatives, you get a negative. Okay, the next question is, can you take an odd root of a negative number? Let's do something simple like the 5th root of -1. Okay, try to make this easy because you can do this in your head. What number would you multiply out 5 times that would give you -1? What? -1. Okay, if you multiply out 5 negatives, you're going to get a negative. So the answer to this problem is yes, you can do it. Okay, so what you want to kind of get down in your head, you don't memorize it, you have to understand it. So if I was sneaky and said, what's the 102nd root of -1, what's the answer to that? No solution, right. What if I did this? What if I did the 99th root of -1? You know what that is in your head? It's -1, right? Okay, odd numbers are okay. Odd roots are okay. Even numbers not. So that's -1. That one is no solution. Okay, you guys understand that? Tell me. Okay, got to understand instead of memorize it. Okay, now let's kind of get our calculators out. Now, not all of you have graphing calculators, I understand that. But one thing that you want to get comfortable with is know how to do roots on your calculator. Okay, if you have a certain model of a calculator, a manual will tell you how to do it, or you can Google what your calculator is, and I'm sure you'll find a manual online for it. So I'm going to kind of show you how it works on a graphing calculator, like a TI type like this. So if you have a TI, what you generally are going to do is you have a math button right here, okay? And if you press the math button, you'll see 2 things that you need to know, okay? First of all, if you look at this option 4, that's a 3rd root. And then option 5 is X root. That means that works for any root. So let me just show you how you would do a cube root. So if you wanted to do a cube root of a really big number on a graphing calculator, you would just press math, go option 4, get that to come out, and then put your number in. Let's do something like the 3rd root of 729. Press enter, there's the answer, okay? Now I want you to notice something on this. If I do 9 to the 3rd, what am I going to get? 729, okay? So you can do a 3rd root on any scientific calculator. Now let's say you want to do a bigger thing, like let's say you want to do an 8th root of 12 for whatever reason. Here's how you do this. On a graphing calculator, you start by typing in the 8. That's the name of the root. Then you go to math. Then you go down to this option that says X root. Then you press enter. Okay, now even if you have a scientific calculator, typically it'll have a X root key somewhere. Okay, that's what you'd want to look for. Then if I put in the 12, that's going to do the 8th root, so it gives you all the decimals. That's just irrational, okay, is what that is. So again, if you were doing this problem, I was going to do the next problem on the calculator because it's a pretty big number. So on a graphing calculator, you would go 4, math, option 5, which is the X root, press enter, and then put in the 1296. So what you want to try to do as a student is you want to do small numbers in your head, big numbers you can use your calculator on. So the answer to this problem, the 4th root of 1296 is 6, but what does this negative do? Just tacks on. Anytime you have a negative outside your radical, it's going to tack on to the answer like that. Okay? All right, does that make sense what I'm doing? Okay, now if you're using a different calculator and you don't know how to do that, just let me know and I can help you figure that out. Okay? Okay, next problem here. Okay, what's the answer to this one?
No real solution.
No solution. How come?
Because the negative solution.
Okay, you have a even root of a negative number. You can't have that. Okay, if you went to your calculator, now some calculators are bad. Like if you have a super cheap $1 calculator, sometimes they don't do this stuff right. Okay, all right. So if you did this same problem, it would go like this. On a graphing calculator, you would go 4, you would go math, option 5, and then you put in the negative 16. If you use a graphing calculator, don't use a subtraction symbol for a negative. Use this one here, the negative with a parenthesis. Do that, look what happens. Okay, get an error. Okay, the answer is not error. I get that in tests all the time. It's no solution. Okay, it's not an error. Okay. Okay, everybody solid with what I'm doing then? Okay, now if we do this one, the way you would want to do this one is, again, you could do, with your calculator if you wanted to, you could just go 4th root. And if you got a graphing calculator, you can try this if you want to. 4th root of 256. Okay, and then that's going to give 4. Okay, now if you do the 4th root of x to the 12th, remember what you're doing is you're doing 12 divided by 4, so that would be x to the 3rd. And if you're doing the 4th root of y to the 8th, what's that going to be? Y to the 2nd. Okay, what's the negative going to do? Makes the answer negative. That negative has no impact on whether it is a solution or not. That just tacks on. It's only the negative under the radical that you got to be aware of. Okay. Okay, let's do, I'd like you guys to try to do the next two yourself. Now, I want you to write this. Whenever you see a fraction, you could do like the 4th root of 625. You can use your calculator to assist you, but you do that, and then you can do the 4th root of x to the 12th, and then you just write the answer. The second problem, you do it the same way. You do the cube root of the top, then you do the cube root of the bottom. Okay, if you can do it in your head, do it in your head. If you need your calculator to help you, get your calculator out. Okay. I've got two other kind of main topics on this section to get us wrapped up. And if you have a calculator that doesn't have a root key, you can still figure it out, but you have to trial and error it. So like on 4th root of 625, you would just try numbers, 2 to the 4th, 3 to the 4th, 4 to the 4th, 5 to the 4th, until you found the one that works. That's the idea, okay? So what number do you multiply out 4 times that gives 625?
5.
5, okay? I know that because it ends in 25. That's how I know that, okay? So that's 5. What's the 4th root of x to the 12th? X to the 3rd. Okay, good. Okay, next problem. What's the answer? 4 over x to the 5th. Okay, it's easy, isn't it?
We have alpha that works.
Okay, yeah.
One doesn't work.
Okay. Okay, the next thing is something that's a little harder. It's a little harder, I think, to understand. I don't emphasize this a lot. You'll see some of this on your homework. But the idea of what we're looking at is we're going to be looking at problems like this, where you have something where the roots match. Okay, like this. You might have 7th root of x to the 7th. Or you might even have something like x plus 3 to the 10th with the 10th root. But the thing we're looking at is kind of a situation where that exponent matches that. Even on that, that's a second root. A square root's a second root, so that matches that, and so forth like that. That's a square root and so forth. So that's what we're looking at. So what you have to do is it depends on whether it's an odd or even root as to how you write your answer. And I'm going to kind of drill you on that first, and then I'll explain why. So it turns out if you have an even root, where these things match, you have the n and n are the same number, then you have to use the absolute value of whatever is under that symbol. So it kind of goes like this. Let me just show you this first of all. Let me give you these two examples over at the side just to kind of help you with this. Okay, first of all, if you look at this problem right here, Okay, well, if you do 6 divided by 6, you get 1, right? So that would be x to the first. Same thing there. That would be 7 divided by 7. That would be x to the first. But here's the deal. When you write the answer to this one, you know it's x to the first, but you have to put it in absolute value, and I'll explain why in just a minute. And then this one, you don't care about it. Okay, so it's like that. And I'll show you with an example in a minute how those negatives work. So before I explain that, what you're going to find on this, and it's real simple, like if you had something like the 5th root of even something like 2 to the 5th. Okay, the answer is 2. Okay, it just undoes that. 5 divided by 5 is 1, so it's 2 to the first. Okay, so what we want to do on this, let's do these, and then I'll try to explain the y part of this first. So this is a 2nd root, so it's even. Okay, so what do you have on this? Okay, all you're doing is those exponents kind of divide out. So what you have is the answer is going to be -9, but since it's an even root, you have to have it in absolute value. Okay, and then the absolute value of -9, what's that? That's 9. Okay, let me explain this. Okay, now watch this carefully. Really, if you're doing the square root of -9 squared, if you forgot absolute value, you would be wrong. Here's why. Watch this very carefully. If you do -9 squared, what do you get? You get positive 81. So this problem is really saying square root of 81. What is that? It's 9. See what happens when you have an even number of negatives, that takes it back to positive. That's why you put that absolute value, because it guarantees that your answer is positive. That's why you must do that. Does that make any sense? Okay? Kind of. Well, that's good for a start.
I get the concept. It's just why, you know.
Okay? In higher math, you have sometimes, like if you have a variable, like if you had something like the 4th root of x to the 4th, the reason the answer is not x is because you don't know what x is.
Right.
It could be negative or positive. So you know you want a positive answer, so you must guarantee that it's positive. That's the reason you do that. Okay? Okay, let's push on. Let's just focus on the even ones here for a minute. This is an even root. Okay? So this next problem's even. Okay, the answer is whatever is being squared. That's x plus 9, right? But since it's even, what do? Absolute value. Problem done. Okay, it's not hard, but it's kind of abstract in what you're doing. Okay, let's go to this one, even root. Okay, the answer is whatever is being squared, but what do? Absolute value, like that. That's how it goes. Okay, now the odd roots go like this. Okay, I'll explain this with this number 33. This is an odd root because that's a 5th power. So what you do is the answer is whatever is being raised to the -5th. But you don't worry about absolute value. That's the answer. Here's why. Let me show you. Hopefully this will help you begin to make sense of this. Okay. If you were doing the 5th root of -3 to the 5th, here's what would happen. Okay, what happens if you multiply out 5 negatives? What answer do you get? You get a negative answer, right? Okay, so if you did this on the calculator, you would get -243. Now, if you turned around and did the cube root, you wouldn't get 3, you would get -3. It's okay to take an odd root of a negative number. Okay, that's what you got to get in your head. Odd root of negative number, good. Even root of negative number, bad. Okay, that's what it boils down to. Okay, got to understand how negatives work. Okay, so keeping that in mind, what do you think the answer of the next one is? This is an odd. You have 2 choices. It's either x or it's absolute value of x. It's x. You don't need the absolute value. That's how it goes. Okay, I know that's abstract. One of the things is I don't usually test over that because the textbook sort of ignores this later in the chapter anyway for some reason. Textbooks do. It's just this shows up in different situations. Okay, to finish this up, I want to do some graphing. Okay, we hadn't done any graphing in a long time, so I'm going to take you through what the graph of some square roots and cube roots looks like. I hadn't done this yet. All we've done is boring lines, so this is not a line anymore. Okay, what I'm going to do with this is we're going to fill in this table of values. Okay, generally when I test over this kind of thing, at this level of a class, I tell you what numbers to use for x. When you're in college algebra, you need to understand more about what we call the domain, and you need to figure out what numbers of x you use. So what I'm going to do is we're going to take the square root of x minus 4. Everywhere when we see an x, we're just going to plug in that number and we're going to calculate, then we're going to graph points. So this first one is going to be square root of 0 minus 4, right? Square root of 0 is 0. 0 minus 4 is negative 4, so that gives us a point. So what you want to do is you want to go down to your graph and you want to plot the point 0, negative 4. Okay, that's just down 4. Okay, we've plotted points before. Okay, go to the next one. We're going to do square root of 1 minus 4. So the square root of 1 is 1. 1 minus 4 is negative 3. So I'm doing arithmetic and I'm plotting points. So you get a point, 1, negative 3. How do you plot 1, negative 3? Over 1 on x, then what? Down 3 on y. Plot points. So you want to go over 1, down 3 like that. Okay, and that's your second dot like that. Okay, move on to the next one. Square root of 4 minus 4. Square root of 4 is 2. 2 minus 4 is negative 2. Okay, so that means we're going to plot the point 4, negative 2. So go ahead and plot that. What do? Right 4 on x, down 2 on y. Okay, so let's do that. So over 4, down 2, hope I'm getting that right. Okay, right? Over 4, down 2. Now see, that right there, square root of 4 is 2.
Oh, okay. The ones on the left are actually exponents.
Okay, like that. Okay, if you can't see that. Okay, does that look like a line? Not really. If it's a line, it's crooked. Okay, so what it actually does is square roots actually do this. Okay, they kind of level off kind of like that. Okay, that kind of is like, what's the shoe? Like a Puma that kind of has a thing, or is that a Nike, or kind of like a Nike swoosh? Okay, so a square root function is kind of like a Nike swoosh. Okay, so it starts at some point and then it swooshes like that. Okay, all right. So that would be kind of the idea. Now I'm going to talk a little bit about domain. I don't test over domain because that's more of a college algebra topic. You might be wondering, why did I give you these values? I'll tell you why I gave those values is because you know the square root of x, right? You know the square root of 1. You don't know the square root of 2 because you'd have to get your calculator out. So I used numbers that I knew square roots of. That's what I did. Okay? Okay, is there any question about what I did with that? So what I'm doing is I'm giving you a table, you're filling the table out, and then you're graphing, okay? That's the idea. So mostly it's arithmetic. Now the domain is going to be whatever x can be. So if you look at a square root has to be either 0 or positive. You can do the square root of 0, that's okay. You can do the square root of a positive number, that's okay. What's not okay is to do the square root of a negative, correct? We've talked about that. So that means the domain, you just write like this. You say set of x such that x is greater than or equal to 0. It has to be equal to 0, so bigger or equal to 0, because if you did the square root of negative 1, you wouldn't get an answer. So that's what your domain is. That's telling you what x is. I don't test over that, but I like to kind of introduce the idea to you. Okay? All right. So, next problem. Again, I'm giving you a table of values. We are going to fill it in and then plot the function. Okay? Now, this time what you want to do is notice that everything is under the square root symbol. So when you plug in the 1, you want to make sure that that 1 minus 1 is under the entire square root. Okay? That's important. So that's square root of 0, so what's that? 0. So there's your first point. Okay, so you want to plot your first point is over 1 and it's on the x-axis. So it's an x-intercept like that. Okay? And then we just move on and continue the same thing. Okay, now we're going to plug in a 2. So we're going to do 2 minus 1. So that's square root of 1. What's that? I gave you numbers that worked out easy without a calculator. So now we get our second point, which is 2, 1. So we plot that point, which just means go over 2, up 1. So you have that. Move on to the next point, which is square root of 5 minus 1. That's square root of 4. So what's that? 2. So you're going to plot the point 5, 2. So go over 5, up 2. Now see, that's kind of got that same shape. It starts somewhere, and then it kind of does something like that. Okay? Square roots always look like that. Okay?
Yeah, we do it within the square root first.
Yes. Yeah, and see, the x minus 1 is under the square root. The whole thing's under the square root, so you have to work it out, then take the square root in that order. Okay, that's the idea. Okay? Now, here's how you do the domain. Okay, again, I don't test over this, but I'm going to just teach you a real easy way to figure out the domain, because on your homework, you'll be asked to do that. What you always do is you write down whatever is under that square root, and you set it greater than or equal to 0. The reason is because what's under a square root has to be either 0 or positive. Okay, then you solve this inequality, which we learned how to do earlier this semester. So that means the domain is x is greater than 1. So notice that I gave you numbers. I started with 1 and I went bigger. Okay? If I gave you numbers less than 1, you would end up getting square roots of negative numbers. So we say the domain is the set of x such that x is greater than or equal to 1. That's how you write that. Like that. Okay?
I'm sorry. How did you do that?
Okay. What you do, okay, I'll show you. If I give you a square root, I don't care what it is.
Okay.
Let's say it's 2x minus 3. And I want you to find the domain. You know that whatever's under the radical has to be 0 or bigger.
Right.
Do you understand why that is? Square root of 0 is cool, right?
Yeah.
Square root of a positive number, cool. Square root of negative, bad.
Yeah.
Okay? So what you do is you do 2x minus 3 greater than or equal to 0. And then when you solve that will tell you what x can be. That will give you good numbers. Okay, so then what you'd do there is you would add 3. You'd have 2x is greater than or equal to 3, then divide by 2.
Okay.
So your domain would be x greater than or equal to 3/2. That's how you do it. Okay? Okay. Now I'm going to do a cube root, then I'm going to do 39, then I'll let you finish up with 40, then we'll go ahead and do our break. So with this one, this is a cube root. Again, I'm going to give you the numbers for x to keep it fairly simple. So we're going to work this out just one by one. We're going to do cube root of negative 8 minus 5. Now notice this time the minus 5 is not under the radical. Okay, so I'm going to do that one at a time. Okay, the cube root of negative 8 is what? Negative 2. Negative 2 minus 5 is negative 7. Now I'm going to go ahead and just get the table filled out, then we're going to go down and plot and graph the points and see what it looks like. Okay, so right now at this stage we're doing arithmetic, so go ahead and just continue with this. We're going to do cube root of negative 1 minus 5. Okay, what's the third root of negative 1? Negative 1. Negative 1 minus 5? Negative 6, and so forth. Okay, now I'm going to let you guys finish that problem and then do the next one. Okay, your turn. I've done too much. See if you can get it. Now you're not going to have a swoosh. This will look totally different. If you do your arithmetic right, it'll look totally different. And don't worry about the domain. I'll talk about that in just a minute. What's that?
Oh, we're drawing ourselves bigger
so
graphs.
small, yeah.
than the one-
Oh yeah, my graph that I gave you is kind of small. I didn't provide a magnifying glass. Arithmetic right, and then we'll check the second one here too. So if you did all your arithmetic right when you finished 39, you would have 0 minus 5, negative 5, and you're going to see these numbers go by a pattern because I made the problem that way. Then the next one's 1 minus 5, so it's negative 4. The next one's 2 minus 5, so it's negative 3. So that's what you should have got in your table. And you got to have your arithmetic down or your graph isn't going to look right. So then if you plotted this point, -8, -7, you're going left 8, and then you're going down 7, kind of like that. -1, -6, you're going left 1 and then down 6. 0, -5 is right on the y-axis. And then 1, -4 is like that. And then 8, down 3 is like that. I hope I did that right because these dots are kind of small. So that's kind of roughly what you'd have is something like that. Okay, I guess John Travolta is doing this actually, huh? Like that. Okay? All right, does that look okay to everybody? Okay? Now, the domain on this is all real numbers. And the reason for that is because of this. When you do a cube root, you can do the cube root of any number. It's different than a square root. You can do a cube root of a negative, right? You can do the cube root of a positive. You can do the cube root of anything. And that's what the domain is. The domain just says, what kind of numbers can you use for x? You can use anything. That's why. Okay? Let's see what we came up with on the next one. Sometimes students mess up on the arithmetic a little bit. Okay? So with this one, notice everything is under the radical. So you would start by doing 4 minus 5, right? Then what would you have to do? You would have to do 4 minus 5 to get -1, right? Then what would you get? -1. You had to do it that way. If everything's under the radical, work it out, then do your radical like that. Okay? Next one, you're going to go like this. Cube root of 5 minus 5. What did you get on that? 0, right? Okay. Next one, cube root of 6 minus 5. What did you get on that?
1.
That's 1. Okay. And then the last one, we have cube root of 13 minus 5. How about that one? That gives 2. All I'm doing is arithmetic. Now you have to do the order of operations the correct way. Okay, so you'd have that. You guys see what I'm doing? If everything's under the radical, work under the radical, then do the cube root. Okay, you got to do it in that order. Okay. Now, if we go through and plot this, we'd have 4, -1, 5, 0, 6, 1, 13's way out here, 11, 12, 13, up to, it still does kind of the same shape, roughly like that. Okay, that's the idea. Now, all we're trying to do in this level of a class is get you comfortable with beginning to do graphs, but graphs of functions is a very big deal in college algebra. And then the domain on this is just all real numbers. It always is on a cube root. Okay? Like that. Okay, so that's that.